Hello, chemists. This is Ms. Placino, and you're watching lesson 10.4 on dilutions. Today we're going to talk about how solutions are prepared to lower concentrations, effectively how they are diluted. Goals for today's lesson. You should be able to recall what type of glassware is used for preparing solutions and dilutions. You should be able to perform dilution calculations. This is the big one. And you should be able to make dilutions of specified concentrations from stock solutions. We're going to be working exclusively in molarity today, and if that term isn't familiar to you, you should probably go back to lesson 10.3 and review different ways of expressing concentration. All right, let's get started. So when we're talking about dilutions, we've got a little bit of terminology to clear up. So first is the stock solution. The stock solution is the solution with a high concentration that needs to be diluted. I remember this because when I go to get a solution, I'm going to go to the stock room. Instead of shipping diluted solutions, most chemical supply companies are going to ship pretty highly concentrated solutions. That way they're actually shipping the chemical to you and not just a whole bunch of water. Often that stock solution concentration is much higher than what you'd need to work with in the lab. For example, something like hydrochloric acid usually gets shipped at 12 molar, which is very, very concentrated, much higher than you'd need for most lab activities, so we'd have to dilute that down. Anytime we go to make a solution or a dilution, we tend to use a volumetric flask. A volumetric flask looks like this, where you have kind of like this bulb at the bottom and then this very, very skinny neck. And it's, I don't know if you can see it at all in this picture, but there's usually like a little line somewhere on that neck called the fill line. A volumetric flask is only able to measure one single volume, but it does so very precisely and very accurately. So for example, in this picture, we have a 500 milliliter volumetric flask. What volume do you think the 500 milliliter volumetric flask measures? Yeah, of course, it's 500. That's the only line on it. So when you filled up the volumetric flask to that line, you can be extremely confident that you have 500, usually 0.00 plus or minus, little volume milliliters of solution. This is the formula we're going to be using for dilution preparation. M1V1 equals M2V2. Those are capital M's, so what do they stand for? Yeah, those are molarities. Molarity, of course, has to be measured in molar, moles per liter. V1 and V2, what do they stand for? Yeah, those are volumes. And truthfully, it doesn't matter if you work in liters or milliliters, just be consistent. Make sure that V1 and V2 have the same units. So when you're using this formula, it's important that you keep the stock solution, your concentrated solution, on one side and the diluted solution on the other. You might find it helpful to just, especially while you're just starting to learn how to use this formula, literally write the words stock and dilution over M1V1 and M2V2 respectively. As I said before, be consistent with units. M should be molarity on both sides, and the volumes can be any volume unit you want. You just have to work in the same one. Don't mix and match volume units. Usually the way this problem works is you will know the volume and the molarity of the diluted solution. So you'll know what you need to prepare both M2 and V2. And you'll know the molarity of the stock solution. So you'll know the concentration that you're working with. Often you are trying to figure out what volume of that stock solution is required to make the dilution. It isn't always this way, but this is most commonly what you would be doing in the lab. My stock solution is too concentrated. I know I need 100 milliliters of 0.1 molar solution. How much stock do I have to measure out to prepare that dilution properly? So just kind of to walk through that process with pictures. What you're going to do once you've calculated the volume of stock solution you need is to measure it out using something like a graduated cylinder. Then you're going to transfer it to your volumetric flask and add solvent to the fill line. So you have done this in this case. You've measured out what you need. You've transferred it to the volumetric flask, the size that you need to prepare the dilution. And then I'm going to continue to add the solvent. Often it's just going to be water until it's up to the fill line. As that happens, I'm diluting down the solution. I've got a whole lot of particles present, kind of per that volume. And then as I add more solvent, I'm going to be lowering the concentration and diluting the solution. Let's walk through an example. We'll do some calculations and talk about what this will look like in the lab. So a solution is made by dissolving 10.00 grams of sodium chloride in enough water to make 500.00 milliliters of solution. And we're going to try to find the molarity of this solution that we're prepping. This is not a dilution problem, this is a molarity problem, so very similar to what we talked about in a previous lesson. I'm going to get into a place where it's a little bit easier for me to write, and we'll walk through this calculation together. If you think you've got it, pause the video, try it out on your own. The first thing I need to do is get the molar mass of sodium chloride. It's about 58.5 grams per mole. So I'm going to take my 10 grams of sodium chloride. And again, I tend to solve molarity using dimensional analysis and not the equation. You're welcome to use the equation if you'd like. I have to get 2 moles per liter for molarity. I can say 1 mole of sodium chloride has a mass of 58.5 grams. That'll let me cancel out grams, and now I've got mole. I know that I need moles per liter. I have milliliters, which is a volume unit, and volume has to go in the denominator. So I'm going to put 1 over 500.00 milliliters. I don't want moles per milliliter, I want moles per liter. So I'm going to do just a conversion. 1,000 milliliters equals a liter. I can cancel out milliliters, and I'm left with moles per liter. All right, so go ahead and perform that calculation, and you should be able to record this to 4 significant figures. I'm coming up with about 0.3419 molar. So here's how I prepare that solution. All right, so I'm going to take my sodium chloride, and using a scale, I'm going to measure out as close to 10.00 grams as I can. Remember, you're going to want to put something like a weigh boat or tear paper on the scale first so that you are not putting the chemical directly onto the plate of the scale. I'm then going to take my 10 grams that I've measured, and I'm going to transfer it to my volumetric flask. So I'll go measured 10 grams, put in the volumetric flask. I then want to start to add water. A rookie mistake is to, have your solute sitting at the bottom and then fill it up to the fill line and then cap it, and then you realize you're going to spend the next 15 minutes of your life shaking that solution to get the solute to dissolve. So a skillful chemist is going to, once they've transferred the solute into the volumetric flask, maybe fill up the bulb about halfway or so. And that way you can really swirl and agitate the solution, and you can get all of the sodium chloride to dissolve. Once it's dissolved, then fill up to the fill line. If you do it beforehand, you're going to spend a ton of time trying to get it to dissolve, and it can be really frustrating. Sometimes it just simply won't dissolve if it's too concentrated. Likely not the case here, but I have seen it happen before. So you want to make sure it is totally dissolved. Then fill to the fill line. You want to be really careful approaching that fill line. You should be down at eye level to measure. And if you overshoot it, you can't just pour some of the liquid out and try again. You're going to lose some solute every time you do that. So technically, you'd have to dump that whole solution and start from scratch, meaning you reweigh the 10 grams, you transfer it, and you kind of approach the problem again. All right. Let's talk a little bit about making a dilution. So we're going to assume that this has prepared our stock solution. So we're going to use that as our stock. How could we make 250 milliliters of a 0.0500 molar sodium chloride solution? Let's do the math on this first. All right, so I'm going to use my dilution formula. M1V1 is equal to M2V2. help keep my work organized, I'm going to put S over M1V1 for my stock solution, and I'm going to put D over M2V2 for the diluted solution. Here's where students usually get confused. The formula itself is not difficult to use. I've got my molarity of my stock solution, we just calculated it. What I see students often do is plug in for V1. Oh, I've got 500 milliliters of that. I got make 0.050 molar solution, and I want 250 milliliters of that. So now I have nothing to solve for. Shoot. This is the common mistake. It's not asking how many total milliliters of the total volume of your stock solution. That doesn't matter. I want to know how much of this 0.3419 molar solution is needed to prepare this dilution. The fact that there are 500 milliliters present is really irrelevant. So I'm going to erase that, and I'm just going to replace it with V1. I'm trying to solve for the volume of stock solution needed to prepare my diluted solution. So now I've got something to solve for. I can plug in, solve for V1, and I should come up with, I got 3 sig figs to work with here, 0.0500. Remember, that's just 3 sig figs. I get about 36.6 milliliters. So I'm going to take 36.6 milliliters of my stock solution, and I'm going to use that to prepare the dilution. And it should look something like this. So I've already prepared my stock. I calculated that I need 36.6 milliliters of my stock solution for the dilution. So I'll take out a graduated cylinder, make sure you're picking one of the appropriate size, and I'm going to transfer that 36.6 mils. Making a mess. Sorry, chemists. So I've measured it out. So maybe I'm here-ish. I need to make 250 milliliters of my dilution. What size volumetric flask do I need? Yeah, the 250. So I've got my 250 milliliter flask. Of course, I'll take the cap off of it before I go to transfer the solution into the new volumetric. Now, just because I've put it in the smaller volumetric flask doesn't mean the concentration has changed. It's still that 0.34-ish molar stock solution. Now what do? Yeah, I'm going to add more solvent. In this case, it just happens to be water, until I get to that fill line. And then at that point, I'll have my 0.0500 molar solution of sodium chloride. Making solutions in the lab can be very tedious and painstaking, but it is something that is exceptionally important. Chemists can't afford to be sloppy when they're putting these together. It can kind of throw off the results of your experiment. You could get some weird looking data. So you want to do it carefully. And really, once you've done this a handful of times, it's something that becomes kind of automatic. But this is an essential skill for any laboratory chemist. You've got plenty of practice problems to play around with for the dilution formula. Just be careful with what you're substituting and where. And remember, the total volume of the stock doesn't matter. What you are really concerned with is what quantity needs to be measured out of that and diluted in order to prepare the diluted solution. So keep on practicing with it. Get comfortable with that formula. That wraps it up for today. Thank you so much for tuning in, and I hope you found this helpful.